In the last class and move to the next section. Kinematics of particles. Kinematics of particles. Kinematics of particles. Alright, 11.3. Okay, I guess this is a typo error. It should be something like this. I told you to collect like terms, have you?
Yes.
And make x the subject. Okay. It appears it is a typo error. So let us try to do something like this and see if we will obtain the answer in their material. Hello? 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 What is it I'm writing? 5 over 3 t cubed minus 5 over 2 t squared minus 30t. Okay, I guess this should be plus 8, not plus 8x. Let's work with this and see what it gives us. So what have we been asked to find? The time, the position, the acceleration, and the acceleration when the velocity is there. So let's get the velocity. So velocity equals the x, the t. So we can differentiate this. When you bring the 3 down, it will cancel this. Okay, and that's going to be 5t squared minus, when you bring the 2 down, it will cancel the 2 below. 5t minus 30. Does that make sense? Do you understand what I'm doing? Alright. So we say when t is 0, so when v is 0, we're going to have 5t squared minus 5t minus 30 to be equal to 0. You can divide through by 5. We're going to have t squared minus t minus 6 equals 0. So you can have factors for this. That's going to be minus 3 and plus 2, right? So when you solve, you're going to get t is equal to 3 seconds and t is equal to minus 2 seconds. Of course, this is wrong. You cannot make any analysis or do any analysis with negative time. You start from time t equal to 0 forward. Does that make sense? Alright, so this is the time at which the velocity is 0. So that is our answer. So the time at which velocity is 0 is t equal to 3 seconds. So we want us to find the time, that is t equal to 3 seconds. The position at that point. So we're going to find x when t is equal to 3 seconds. So you can put your calculator. What does that give you? That's going to give you 5 over 3 into 3 raised to the power 3 minus 5 over 2 into 3 raised to the power 2 minus 30 into 3 then plus 8. What does this give you, please? And then you can get the acceleration. To get the acceleration, differentiate the velocity. So acceleration equals the v dt. So that is going to give you what? Derivative of velocity. That is 10t minus 5. Does that make sense? Derivative of velocity is 10t minus 5. So at time t equal to 3 seconds, acceleration is going to be equal to 10 into 3 minus 5. That's going to be 30 minus 5, which is 25 meters per second squared. So what did you get from this? Anybody has done that? Was that what they got in the book? Yes. Okay, so it's a typo error. Just ignore that x on the right hand side.
What if that x was there actually? How was it?
Yeah, that was what I told you that you collect like terms and make x the subject. Do you get that? Collect like terms and make x the subject. So that is that about that. So let's move on to the next set of problems. I would love you to actually listen, please listen. Like I told you then, we don't have the time to solve all the problems together in class. So what I want you to do right now, I want us to end this section today. What I want you to do right now is look through all the problems left and tell me which of them you think we might need to solve together. You know, that's what I just said. Okay. Look through all the problems left in this section and tell me if you think we should solve any one of them together. Did you get what I just said? look through all the problems left and tell me if you think we should solve any of the problems together. Please do that now. Do that now. I'm waiting. Look through the problems left. Let me know which of them you think we should solve together. If you don't think we should solve any one of them together, that means I believe you can solve them all on your own. Or you believe you can solve them all on your own, which means we are good to go. We can move to the next section. Please look through the problems left. Look through the problems left and let me know if you think we should solve any one of them together. What else? If I need to talk, once we are done here, I want to move on. So we're going to solve others alone. Okay, I want to move on to the next section. I want to move on to the next 11.17. 11.17. What else? Oh yeah. Did you get what I just said? We cannot solve all examples or all exercises in this class. Okay? There will be no time to do anything at all. We decide to go that far. So I'm saying that you should practice the problems at home on your own. But now I want you to look through the problems and tell me which one of them you think we should solve together in this class. That will be the end of this section. And we will move to the next section after that. So 11.10. Let's do 11.10. 11.10. Are you there? 11.10. The acceleration of the particle is directly proportional to the square of the time t. When t equals 0, the particle is at x equals to 24 meters. Knowing that at t equals to 6 seconds, x equals to 96 meters. So what kind of problem is this? Now I gave you different kinds of problems the other day. I gave you like 4 of them that you may come across. You may come across what we call, please pay attention. You may come across a situation where x is defined as a function of time. You may come across a situation where acceleration is defined as function of time. Acceleration might be defined as function of position, x. Acceleration might be defined as function of velocity, v. Okay, and you may come across uniformly accelerated motion, which I said also applies to uniform motion in the case of motion with constant velocity. So this is one of such cases where acceleration is dependent on time. So you have been told that acceleration is proportional to the square of time. Does that make sense to you? Okay, so we said acceleration is proportional to the square of the time t. So that means I can say that acceleration is equal to kt squared, where k is that constant of proportionality. Does that make sense to you? Okay, so that is what we have over there. Then we are told that, please pay attention, when t equals to 0, the particle is at x equal to 24 meters. So we are given x at a particular time. That means when we want to relate x and t, we can use that as our initial value. Then we go on, they say knowing that at t equal to 6 seconds, x equal to 96 and v equal to 18. So we are also given a relationship with this second information. We are given a relationship between t and v. Okay, so we can do right now. Please pay attention now. So I know that if I need to get v from here, I can integrate this equation. I know acceleration is the v dt. So I'll be given that the v dt equals kt squared. Does that make sense to you? Okay, so I can integrate this. That means that the integral of the v is equal to integral of kt squared dt. Does that make sense to you? Do you understand that? Are we together, please? Please concentrate. Please, I need to concentrate. You have been told that at time t equals to 6 seconds, v equals 18. So when t equals to 6 seconds, I'm going to put that here. V equals 18. So I'm going to have that here. So I want to find out what is v at some arbitrary time t. Does that make sense to you? I want to integrate. So I'm going to use this as initial value. So I will not have to deal with any thing like constant of proportionality here. Is that sorry? Constant of integration here. Does it make sense to you? So that information will help us make this a proper integral so that we do not have to deal with any constant of integration, and you can get this result directly. So this is going to give us what now? The integral of 1 with respect to b, that is v, abi. So v running from 18 to v is equal to integral of this, that will be k t to the power 3 all over 3 running from 6 to t. So this is going to give me v minus 18 is equal to k t to the power 3 all over 3 minus k 6 to the power 3 all over 3. Does that make sense? Do you understand what I'm doing?
Yes.
Do you understand what I'm doing?
Yes.
Do you understand what I'm doing? Are you sure you understand what I'm doing? Are you sure you understand this? Are you sure you understand this?
Yes, ma'am.
Okay. Are you sure you understand this? Some of you are looking like. So this is going to give us v is equal to 18 minus k, plus. Let's see, right? Let's write the k first. K c cubed over 3. Okay. Minus 6 raised to the power 3 is 18. Sorry. That's not 18. 6 raised to the power 3 is what? Huh? 6 raised to the power 3. 216. Divided by 3, what is it?
72.
17. So this is going to be minus 72. 72. Okay. Minus 72k. Then when I move the 18 to the other side, that will be plus 18. Does that make sense? So that is our v in terms of t. Of course, we still have our constant of proportionality. We cannot evaluate that yet. We don't have sufficient information to evaluate the constant of proportionality. Now, I can go for that to get x. Okay, I can go for that to get x by integrating this. I know that my v is equal to the x dt. So I will say that the x dt equals k to the power 3 over 3 minus 72k plus 18. Does that make sense? Are we together, please? Did you get what I'm doing? Okay, so I will integrate this again. That means the x is equal to k t cubed over 3 minus 72k plus 18 dt. So I can integrate this. So with respect to t. So please listen now. You know, we have been provided with two information. We are told that when t equal to 0, the particle is at x equal to 24 meters. Can you see that? Alright, so at t equal to 0, x is actually 24. So I want to find x at some arbitrary t. Is it clear? Does it make sense to you? Do you understand what I'm doing? Well, I told some of you, I told all of you, if you have issues with how to integrate, which is something you have done since 100 level, the 200 level classes I assume you know how to differentiate and you know how to integrate. So those are not things I should be teaching you. They are things you ought to have learned before you get to 200 level. And I told you after your first semester exam that you should go home and learn them properly if you have not learned them. So I don't think that should be the issue here now. Okay, so these are just applications of integration that you have done before actually. These are further mathematics questions. SSC, further math project 2. You study further math project 2 properly, you should be able to solve these things without even these classes you are doing together. So this is going to give us something like this. So this is going to be x, and so that will be x minus 24 is equal to, I just inserted it directly, but let's not confuse ourselves. It's going to be this, it's going to be equal to, can integrate it, that will be k t to the power 4 divided by 12. Does that make sense? Minus 72 kt plus 18. So I will run this from 18t. Thank you. So I'll run this from 0 to t. So I'll carry on the integration and we will get x minus 24 equals, so I'll put in t. When I put in 0, everything is going to be 0, so I don't have to bother about 0. So this is going to be kt to the power 4 plus 12 minus 72 kt plus 18t. Yet, I have not been able to evaluate the constant of proportionality. But I'm given another information here. You can see on the second statement says when t equal to 6, x equal to 96. Can you see that? I know that when t equal to 6, x equal to 96. So I can use that information here to find the value of the constant of proportionality, k. Is that clear? Do you understand that? Okay, so when t equals to 6, so I will write that because when t equals to 6, x equals 96. So with this, I will substitute here 96 minus 24 equals k into 6 to the power 4 all over 12 minus 72k into 6 plus 18 into 6. Does that make sense? So you can have this simplified. So what does it give you, please? You can solve it now, right? You should be able to solve this. 6 raised to the power 4 divided by 12. Put them together, collect like terms, and then find the value of k. What does it give you? I believe everybody can do that. What does it give you? What's that? What was your job? Like I said, MTH202 past question will be available tomorrow for 1,600. And MTH202, I doubt MTH202 will be available in the morning. If you have class in the evening, yes, you should be able to get it by evening tomorrow. How many? 1/9. Okay. K equals 1/9. So having established this, we can now get actual expressions for V, for A, and for X. Is that clear? So we can get an actual expression for X now. So when you substitute 1/9 here, what are you going to get? That means X equal to, so I'll put 1/9 here. 1/9. Do you understand that? C to the power 4 divided by 12 minus 72 multiplied by 1/9 T plus 18 T. Does that make sense?
Plus 24.
Yeah, plus 24. Thank you. We're going to move that right here. So what does it give you? You can simplify each term. So x equals 1/9, that's 9 times 12, right? What's 9 times 12? 120 minus 12, 108. This is going to be t to the power 4 over 108. And minus 72/9 minus 8t to the power, okay, just t.
Yeah.
Then plus another 8t. That's going to be 18t. So that's minus plus now. It will be 0 like that.
No, like
How should be 18?
that is when you 18.
Okay, this one is 18.
Yeah.
Okay, this is going to be 18. Okay, that will be 18 minus 8, Abby. That will be plus 10c. Alright, thank you. Plus 24. Alright, plus 24. So if you differentiate this, it must give you the same result as when you substitute k here. Do you understand what I just said? If you differentiate this, it must be the same thing as substituting k here. Or differentiate the result, it must be the same thing as substituting k here. Does that make sense? Alright, so we can get v by differentiating this. V equals to, or you bring this down, 108 divided by 4. What is it? 108 divided by 4. 108 divided by 4. Yeah? 27. So this is t power 3 over 27 plus 10. Okay? That is our v. So you are going to see that when you substitute k here, it's going to be minus 8 plus 18. Abi? Which is plus 10. Does that make sense to you? And when you substitute 1/9 right here, I'm going to have 1/9 times 3, which is 27. Is it clear? So that confirms that it is okay. Then when you differentiate this, you get or differentiate this. 27 divided by 3 is 9. Abi? That's going to be t squared over 9, which is exactly the same thing as putting 1/9 right here. Is that clear? Do you understand that? So anyway you do it, you will get those results. So you now have X, B, and T. Okay, whatever you've been asked for. Basically, this is what you need actually. Once you have obtained this, you know you can obtain every other thing in the system. Do you understand this idea? So that is the actual problem. So we should, knowing that express V and X and V in terms of T, so that's what we just did. So the problem is now solved. This is our result. This is actually what we need from the okay. So that's not about that. So quickly write that and we move to the next problem. Quickly write that so that we move to the next problem. Oscillate between the point x equal to 40 mm and x equal to 160 mm with an acceleration a equals k into 100 minus s, where a and x are expressed in millimeters per second square and millimeters respectively, and k is the constant. The velocity of the particle is 18 millimeters per second when x equal to 100 mm and is 0 at both x equal to 40 and x equal to 160. Determine A, the value of k, B, the velocity when x equal to 120 mm. Alright, so I've told you the other day, listen now, you will usually have the problems in this form. For those of you who did not come, the problems will usually come across here. This is that you have x as a function of time, or you have acceleration as a function of time. Like the one we just did now was acceleration as a function of time. What you do is you just integrate down until you get to x as function of time. Does that make sense? Okay. The point is, solving the problem means that you are able to get x as a function of time. Do you understand that? Once you are able to do that, then every other thing follows easily. You will be able to obtain every other parameter you want to get. Okay, so you can have a as the function of x. Okay. You can have a as function of velocity. Okay. And then you can have a to be a constant. These are the different forms you can have. And when you have a to be a constant, you can use the equations of uniformly accelerated motion. The constant means it does not depend on any other variable. Okay? It is just a number. Right? Look at this. When it depends on velocity, you're going to integrate, get velocity. Then integrate velocity, get position. That's x. The same thing here. You're going to integrate this, get velocity possibly, and get position as function of time. Okay, so and the equation you will use here, the equation we will use in all cases are a first one is v equal to the s dt. A is equal to the v dt, and we have the last one. When you eliminate the t from this, you say a the x will be equal to v the v. These are the tools you have. These are the forms the problem will usually come. So when you have any of these forms, you look at which of these equations will be appropriate to form your differential equation. Usually a first order differential equation at every point. Then you can integrate and obtain your x as a function of time. So the destination in all cases is being able to obtain x as a function of time. The destination is you're able to obtain x as a function of time. Once this is obtained, we say the motion is defined. Because with that, you can obtain every other parameter for the moving body. Does that make sense to you? Okay, so that is the idea here. So look at this problem, 11.17. You have, what kind of problem is this now? This is of the type A equal to f of x. Can you see that? This 11.17, are you all there? Can you see the question? 11.17. I hope you all have the book. Someone can help us screenshot and post on the group. If you just registered this morning and you were not around, you were not with us last semester, so you did manage your number. Registration form will be available tomorrow, so you can fill this form. But before then, give him your number so you can be added to the WhatsApp group. So I'll send it to the group. If you don't have the book, are you there now? So So look at this. So it says a particle oscillates between the points x equal to 40 mm and x equal to 160 mm. Listen very well. Oscillation. Listen, oscillation like you have a to and fro movement. Abi? Now it is still rectilinear motion, something going to and fro on a straight path. What makes it rectilinear is the fact that it's going on a straight path. Is it making sense to you? Okay, it's not the fact that it goes forward and backward. Of course, I told you that is why we have turning points. That's why a body can move forward and then return back. Do you understand what I'm saying? So it can as well be oscillating. That doesn't stop it from being a rectilinear motion. Does that make sense to you? Okay, so in this case, we are told that acceleration equals k into 100 minus x. So obviously, you have been given what? You have been given acceleration as a function of position x. Is that clear? So this is a problem of this third kind. Is it making sense? And what do you do now? You integrate so that you can get x as a function of time, okay? V as a function of time and so if you need it. That's what I'm saying. Alright, so what equation do you think is appropriate here? You can use this, Abi. A dx equal to b dv. Is it making sense? Why can you use that or why should you use that? Because obviously you cannot use this one. If you want to use this now, you are going to have the v dt equal to this. So you won't be able to separate the variables because you are going to have three variables at the end of the day you cannot integrate. So if you put in the v dt is equal to this, you are going to have v as a variable, x as a variable, t as a variable. You can't deal with three of them at once. Do you understand what I'm saying? Okay, but you can use this relationship. A dx is equal to b dv. So we know a dx is equal to what? A dx is equal to b dv. So we now substitute for a. I'll be given this to be a. That means k into 100 minus x dx is equal to v dv. Does that make sense?
Yes, sir.
So now I have only two variables, x and v. So I can integrate this with respect to x, this with respect to v. Is it clear? So to make it a proper integral, we will look for an initial condition or initial value that we can use from the information supplied. So you look at the problem, 11.17, look at it. We've been told that the velocity of the particle is 18 millimeters per second when x equal to 100 millimeters. Can you see that? Can you see that in the problem? Alright, so when x equal to 100, velocity was 18. So I want to find x at some arbitrary p. I want to find v at some arbitrary x. Is that clear? So with this, I can move on to carry out this integration. So integrating this, what are you going to get? K is a constant, so I can move it out of the integral sign. So I'm going to have this to be 100x minus x squared over 2. Do you agree with that? Then from 100 to x is equal to v squared over 2 from 18 to v. Does that make sense to you? Do you understand this? Integration, it's quite straightforward integration. Please always come early. We will start 7. Please always come early. Please always come early. Okay? Plan to get used to it. No, you usually wake up late. So if you usually wake up late, it's probably because you sleep late. So try and sleep early so that you can wake up early. I want to wake up. If it's 5 a.m. or 6 a.m., go and have a bath immediately and start coming. If you're still feeling sleepy or anything, you can get there and sleep further. It's not easy. Yeah, I know it's not easy. 11 points. The time is the next one. Do what we're done with this. Yeah.
What are you looking at?
6 a.m. How about getting up from 6 a.m.? So far.
People school say no, they give us everyone.
Can we move on, please? So this is going to give us what? When I substitute, I'm going to have k into 100x k into 100x minus x squared over 2. That is when I substitute x. When I substitute 100, I'm going to have minus k into 100 multiplied by 100. Let me use the square bracket here. 100 multiplied by 100 minus 100 squared over 2. That's what I will have on the left hand side. equals the right hand side. I'm going to have v squared over 2, v squared over 2 minus 18 squared over 2. Is that clear? Is this clear? So, with this we can simplify what we have here, and we're going to have this to be. So I can pick v. I want to make v the subject. When I multiply all through by 2, multiplying all through by 2, I'm going to have v squared minus 18 squared is equal to, when I multiply this all through by 2, I'm going to have k into 200x minus x squared minus k into, what is this one? 100 times 100. That's 10 raised to the power 4, right? 10 raised to the power 4, right? So when I multiply it by 2, that will be 2 times 10 raised to the power 4. That will be 2 times 10 raised to the power 4 minus, when I multiply this by 2, this will play off this 2 I have right here. Does that make sense? Yeah? Do you understand that? You cannot multiply that. It's now you put it outside and leave everything the way they are, or you multiply what's inside and leave it the way. Do you understand that?
Yes.
So this is going to give you minus 100 squared. That is going to be 10 raised to the power 4. Do you understand that? That's like 2 times 10 raised to the power 4 minus 10 raised to the power 4. That's going to be 10 raised to the power 4. Does that make sense? Okay, so this is going to be this, and then you can simplify for that. V squared is going to be equal to, so you can open the brackets if you like, or just keep them the way they are. This is going to be equal to k into 200x minus x squared, and minus, so 2 times 10 raised to the power 4 minus 10 raised to the power 4. That is 1 times 10 raised to the power 4. Is that clear? So this is going to be equal to minus 10 raised to the power 4. That's what you have right here. Then we have 18 squared plus 18 squared. What is 18 squared? I calculate what is 18 squared? 324. So that is about that. So we have v in terms of x this way, and then we still have an unknown k. Okay? But we can move ahead to look at the other information supply. We said the velocity of the particle is 18 millimeters per second when x equals to 100 and is 0 both at x equal to 40 and x equal to 160. Can you see that? That means the velocity of the body is 0 when x equal to 40 and it is also 0 when x equal to 160. Is that clear? So I know that when x equal to 40, v is equal to 0. Is that clear? So I can go ahead and simplify this with that. Is that clear? So this is going to give me v squared. That's going to be 0 squared equal to k into, this is going to be 200 multiplied by 40. Let me use a square bracket here. 200 multiplied by 40 minus 40 squared and minus 10 raised to the power 4 plus 3 to 4. Is that clear? This one is 0, so that is out of the equation. So you can simplify whatever is left and use it to solve for k. What does it give you, please? Alright, I need to rename. What is k, please? Why your k? Yeah, what did you get? Nine over 100. Okay, 9 over 100. That means you are good to go. So we can now write v squared equals, pay attention now, pay attention. No. We get to this in 2 days later. So look at this. This is going to give us what? V squared is equal to, we are not done with the problem yet. V squared is equal to, I can put in 9 over 100 to 200x minus x squared and minus 10 raised to the power 4 multiplied by 9 over 100 then plus 324. Does that make sense? You get it? So this is going to give us what? It's going to give us v squared equal to 9 over 100. So this is going to cancel this. It's going to be 18. When you open the brackets on the first one, that's going to be 18x minus, it's going to be 9 over 100 x squared. That's going to be 9x squared over 100 minus 9 over 100. 100 we cancel 2 of this, Abby. We need to have 100 left. That's going to be 900 plus 324. Does that make sense? What does that mean with this? So we have v squared is equal to 18x minus 9x squared over 100. What does this give you? Minus 5, 7, 6. Alright. So check it now. When x equal to 40, what is v? X equal to 40 in that expression. What will v give you?
When x equals to
40. I will do it as a check.
v0.
V0. Alright. When x equal to, what's the next one? 160, Abby? When x equal to 160. V0. Alright, so we are good to go. So let's move on now. They said it should determine the value of k. Okay, we have done that part. K is equal to 9 over 100. So this is one of our solutions. Is it clear? It's part of our solutions. Then the next one says we should determine the velocity when x equal to 120 mm. Can you see that? The velocity when x equal to 120. So you can get that also. What would that give you? Oh, yeah. When x equal to 120, what will be the velocity? When x equal to 120 mm, of course everything is in mm. V is in millimeters per second. So what is our V? Do whatever you want to do and take the square root. 16.97. Is it positive or negative?
Positive.
How did you know? Is it positive or negative? Is it positive or negative?
How was this process?
X equal to what? What did you get just now? 60. 16.97 mm per second. This is either positive or negative, and either of them can be correct. So we need to find a way to verify which of them is the appropriate. Let's see if we can get that from the information supplied.
You shall always shake up this camera, so you don't start like 3 times.
You know that I am.
So this is it. Look at the information given to us. They said, please listen. They said a particle oscillates between the points x equal to 40 mm and x equal to 160 mm with an acceleration a equal to k into 100 minus x. Please pay attention. So you want us to get the velocity when x equal to 120. Please listen very well. It's oscillating, so that means that when it gets to x equal to 40, it will start, between x equal to 40 and x equal to 160. So x equal to 40, it will turn back to x equal to 160. As x equal to 160, it will turn back to x equal to 40. Do you get that? It continues oscillating like that. That's why the velocity was 0 at 40 and also 0 at 160. Is it clear? So at 120, listen now. Depending on the particular time you are interested in, that velocity could be positive or negative. Do you understand what I'm saying? Because at x equal to 160, let's say this is x equal to 40, and this is x equal to 160. If it is moving this way, that is, if it goes from 0 here and it is moving towards this, okay, it could be at that point that it attained 120, or it was at position 120. Do you understand that? When it is going that way, it's going to have a positive velocity. Is it clear? And then when it is coming this way, it's going to have a negative velocity because it is moving in the negative x direction. Is that very clear? Do you understand what I just said? Do you get what I just said? It is oscillating, so it will go this way, come here, return here, go, come, return. Do you understand what I'm saying? So that means at this point, the velocity will either be positive or negative. For you to know the exact sign, it means you ought to have been given time instead of just x. Is it clear? Because when it is at this position, it can be positive or negative. Because it could be at this position and at that instant, it could be moving this way. And it can happen that at that instant, it is moving this way. Does it make sense to you?
Yeah.
About the question, velocity that
Hey, fine, yes.
No.
it's
Neither decreasing nor increasing. This is the idea. The acceleration changes with position. You get that? The acceleration changes with position. Can you see that? The acceleration changes with position. Okay, so it will have different acceleration at different points. But at the end of the day, it is such that the velocity is 0 here, the velocity is also 0 here. You get what I'm saying? So it will be increasing at some point and then it will start decreasing later, so that it will become 0 by the time it gets here. Do you understand what I'm saying? You cannot tell. So this is meant to be V is equal to plus or minus 3.90. Does that make sense?
Yeah.
Plus or minus. So it depends on whether it was going forward or backward at the instant under consideration. But we know that the velocity at that point is only 3.97 meters per second. Is that clear?
No, but if the velocity at 150 like 6, what would be the value?
Hey, if it was, that means the only its implication will be in the when we were obtaining this velocity. I mean, that means the constant of integration that we this constant of proportionality that we got now add a different value. Do you understand that? Yeah? Yes, now yes. So far it is oscillating. Yes, it's still a plus or minus. So far, and the reason we are doing that is because we are dealing with position. So at this position, when you find it at this position, it might be that it is going this way at that instant, and it might be that it is coming this way at the instant. So we don't know which one of them. We just want us to get that x equal to 120. So that is the idea. So it could be positive or negative. If you add a specific time, we might want to find out where is the velocity at that point and where is it facing at that point. And we want to find out other details too to help us establish where exactly it is going at that instant. But we don't have such details. You know, if it was time, you would just integrate this for that and get x as a function of time. Then you get the turning point for x. Do you get what I'm saying? Or you get the turning point, and at a certain time you can tell whether it is going forward or coming backwards at that instant. But you can't do that with the information like that. Do you get me? Because to be at x equal to 120 at different times is undergoing oscillation. Alright, can we move on now? Can we move on? Yeah. I didn't hear you. Or if you are given the velocity. Yes. If you are given velocity to find position, you know that the position could also be positive or negative. Abi?
Yeah.
Okay, but in that case, we know that position cannot go negative. Do you understand that? From the detail of the problem, they say it is oscillating between 40 and 160. So if you are given anything, if you have anything that is less than 40 or greater than 160, that's the one you are going to ignore. Do you understand that? to be the one that is within that range. That is your correct answer. Does that make sense to you? Alright. But in this case, the velocity can be either positive or negative at that stage. So that's what we are leaving. Let's move on, please. 11.29, right? That was the other one. 11.29. Let's locate 11.29. So usually, when you are, listen please, usually when you are going through this material, you can always ignore anything about solar system. You can always ignore any question that has to do with solar system. But we'll show this. 11.29 on the group. The acceleration due to gravity. The acceleration due to gravity. You should all have the textbook. So the acceleration due to gravity at an altitude y above the surface of the earth can be expressed as a is equal to this blah blah blah, where a and y are expressed in feet per second square and feet. Okay. So what do you think? What kind of problem is this? Think about it. That's a function of position. A is equal to f of x. Abi? Just that in this case, the position is expressed in terms of y and not x. That's the only difference. Did you know that? So you are still going to use the same equation. A dx is equal to b dt. Very. Do you understand this? Can you give it a try now? Oh yeah, give it a try, everybody. Can you give it a try? If you are unable to try, if you are unable to do something correctly with something. Oh yeah, give it a try. Oh yeah. Oh yeah. Operation of parameter. Let's read this together. They said, using this expression, compute the height, please listen now, the height reached by a projectile fired vertically upward from the surface of the earth. If its initial velocity is a 1,800 feet per second square, please pay attention, pay attention. Its initial velocity will be the velocity when y is 0. Does that make sense to you?
Yeah.
Well, how did I come about that? It said it was y represents the altitude above the surface of the earth. Do you understand what I'm saying? So its initial velocity will be the velocity with which it left the surface. Is it clear? So that initial velocity will be the velocity when y is equal to 0. So you want to find the height it reaches. That means you want to find the y when v is 0. You know at the maximum height v is going to become 0. Does it make sense? Did you get what I just said? The height it reaches will be the value of y when v is 0. Does that make sense? Do you understand what I'm saying? At the maximum height of any projectile, anything that goes up, okay, anything you fire at the maximum height, its velocity will become 0. Am I making sense? So you want to find y when v equals to 0. That's going to give you the maximum height. Is it making sense? So just carry out the integration that we just did now, so that you get v in terms of y. Do you understand? Instead of v and x, you're going to have v and y. Just a change of a variable. It doesn't change any if you find it difficult to integrate that v, you may try to expand it.
Like that.
If it looks like it
Why over everything like that, or why over 20 times?
Why over 20.9? Why over 20.9? Division before multiplication.
Are you sure?
And now, why over 20.9 on their own? 10 times 10 is over. I said division before multiplication. Isn't that the normal order of operation, you know?
Yeah.
What maths?
The way they wrote it, like
mass.
it was y
Standard
over.
form.
If they meant it that way, they will put it in brackets. Just let you know, the brackets first. You get that?
I think it was ever.
Because
So what are we doing? Off and on. What is the off and on?
Yeah, to expand.
Okay, you want to expand it?
Yep.
I don't know.
One.
Go they judge
What
it.
is this? I get it. Special. So late.
This is the
Everyone that is out there.
Okay, what if you set the denominator to that expression inside the square? Set it to a certain variable.
See everything.
You can say let u equal to 1 plus y over 20.9. Do you understand what I'm saying?
What differentiates this guy with
Did
this?
you get that?
Let's do it.
What do you have in the bracket? Okay, one.
Oh, I suppose that.
This is just
But what was the
That's so you are unnecessarily confused because of the nearest power something.
If you calculate it as 10 plus 6y over 21. Yes.
A is equal to minus 2.2 all over 1 plus y all square. You'll be able to integrate something like this. Eh? Look at the board, please. Look at the board. Will you be able to integrate something like this if you are given? A is equal to minus 32.2. 1 plus cy power minus 2. Can you integrate this? Can you integrate this?
Yes.
Exactly now. That C is your 1 over whatever you have here. Do you understand that? That's your 10 raised power 6 over 20.9. Do you understand what I just said? That's what I have represented as. C is representing, in this case, 10 raised power 6 divided by 20.9. Does that make sense to you? Okay, so nice. So, can you integrate this? So what does it give you? The way the number looks, it makes it look like it's something very complex to integrate. That's why I've removed the number and replaced this. So when you are done, you can put back the number. Do you understand me? It's a constant, so it does not affect your results.
Max, should be the integration divided by the integral of what you got? And the differential.
Calm down, Father.
Okay, please look now.
I don't understand. Like differential. Max, it's coming down.
Minus minus 1. A is equal to, that means d dy, Abby, equal to d dv. Do you understand what I'm doing? And the figure minus 32 over 0.2 is a constant, so no issue with it. Yeah. Then you can do, okay, what did you get from the integration? What did you get? Minus 1. How did you get minus 1? Okay, you bring this, Abby.
Yeah.
So you know that denominator, Abby. So now it's going to be minus 1 all over 1 plus cy, Abby. Raised to power 1, Abby. That's 1 plus cy. Abby now. You have minus 32.2 outside. Is that clear?
Yeah.
Okay, multiply by c, Abby. Divided by c. That's going to be c into 1 plus cy. Then this minus will cancel this minus. I have 1 here. Then this is going to run from whatever limit you have equal to b squared over 2. From whatever limit you have. Does that make sense? So you can try and differentiate this now. If you differentiate it and you don't get the original thing back, that means you have done something wrong. Abi? How will you differentiate this? Bottom the top, Abi, minus top the bottom. Am I making sense? So that's going to give you what? If you want to differentiate this expression, minus 1 over c into 1 plus cy, what does it give you? This is going to be bottom the top. Derivative of the top is going to be 0. Abi now? The numerator is a constant. The derivative is 0. Minus top the bottom, that's minus 1, multiplied by derivative of the bottom. Don't forget, this is going to be c plus c squared y. Abi? So the derivative of the bottom is going to be c squared. Does that make sense to you? Do you understand what I'm doing? Okay, all over bottom square, that's going to be divided by c squared into 1 plus cy all squared. So this will cancel this. Minus of minus 1, that will be 1. Is that clear? So it will be 1 over 1 plus cy squared, which is what we started with. Does it make sense to you? Right, so that is the integral. So, having done this, you can then replace your c later on. Do you understand what I'm saying? You know what c is. I can't be teaching integration. I can't answer your questions on integration. I'm going to go and learn integration. What is it? I can't answer a question on integration. What is it?
Stop them out, stop them. Do what they do. What are you doing? They don't think. Or if you do yes.
It's fine, you should get the same result. You get the same result.
My finance.
Go continue.
No, I'm telling you, if they say,
It should be correct now. By the time we multiply, by the time you divide that by that c, that may be the same thing like that. It be correct now. Multiply this c, I mean divide 32.2 by this. If there is power minus 6 that you have here,
When y is
the original equation. 6
after integration. When y is
Okay, well this is the result. Do you understand this one? Do you understand this? Can we move on?
Why?
It is definite. I'm not putting the values here. So look at it now. Look at what they said. So they said, please pay attention now. So I'm going to do the A part. The only difference is in the value of the initial velocity. Do you get what I'm saying? So they said you should find the, please listen now, listen. Compute the height reached by a projectile fired vertically upward from the surface of the earth if its initial velocity is A, 1,800 feet per second. Can you see that? So if its initial velocity, that means at y equal to 0, our v was equal to 1,800. Is that clear? That is for the A part. So we can do others the same way. The only difference will be the initial value that you put for V. Is it clear? So v is equal to 1,800 when y is equal to 0. Does that make sense? So I want to find out y at any v or v at any y. Does that make sense? What's the issue now?
Okay, that's
Is there any problem? Any problem at this point? Is there any problem? Apart from the integration, is there any problem? You don't understand what we're doing? Let me know. Okay. So this is going to give us what now? I'm not using the C yet, so just leave it like that. This is going to give us 32.2 into divided by C into 1 plus cy. Then when you put 0, this is going to be equal to minus 32.2 divided by C Abi into 1 plus C into 0. Does that make sense? And this is going to be equal to v squared over 2 minus 1800 squared all over. Does it make sense? Did you understand that? Yeah. Alright, so this is going to give us that. And this is 0, so that is gone. So we have only C at the denominator. Right? So this is going to give us when you multiply through by 2, for instance, just to clear the fraction for v, I want to make v the subject. I'm going to have v squared equal to, so I can write what I have here. 2 times this is going to be 64.4. Do you understand that? So this is going to be 64.4. Do you get that? So I'm just moving this out. And this is going to be equal to 1 over c into 1 plus cy minus 1 over c. Then I'm going to move this to the other side. That is going to be plus 1,800 squared. 1,800 squared. You understand what I'm doing? Do you get that? By simple rearrangement. So that means you are good to go. Okay? That is going to be the relationship between v and y. See, there's no need to fine tune it or substitute c or anything. You have a destination you're going. When you get to the point of writing your final answer, you can put c back. You understand what I'm saying? Okay, so look at this now. So we want to get the, please pay attention, we want to get the, using this expression, compute the height reached by a projectile fired vertically upward from the surface of the earth. So, at the maximum height, or at the height, okay, we're going to have v to the 0. So I want to find out what is my y when v equals to 0. Is that clear? So I'll find out when v equals to 0, what is going to happen? That means I'm going to have 0 to be equal to 64.4 into 1 over c into 1 plus cy minus 1 over c plus 1800. Right. So you have everything. So make y the subject. Make y the subject, and that will be in terms of c. When you get to that point, you can now substitute for c. Is it clear? Is this clear? Make y the subject. When you've done that, you can substitute for c. Don't forget, c is 20.9 times 10 to the power something, or 10 to the power something divided by 20.9. So you're going to put it back there when you get to y.
Overnight.
You guys woke up.
I did tell you.
You don't say we never start. David, you don't say we never start. What's the final answer? What do you hide, Bobby? Yes, it should be.
Just minus.
I got y as minus 1.0.
You go y to the negative.
This is about 6 over 20.
Okay, 10 is power 6 over 20.9.
Yes.
Okay, use 20.9 times 10 is power 8. Sorry, 20.9 times 10 is power 6. What does it give you?
You wrong me. How did we okay to have this in money?
Sorry, bro.
See now.
Use 20.9 times 10 is power 8. What does it give you? 6, rather.
No, you can use 20.9
Okay, send my.
Now,
think minus 2 plus
To be
6.
said,
Which one
it's
are you talking about?
Abeg, how far now?
10 plus 6 divided by 20.
You ready? You?
And then now.
Let's have it.
Yeah.
Okay, try that. What does it give you?
I don't know.
That's on beginning we'll go to.
Oh,
It's 1 over
1 over
20.9.
20.9 times 10 raised power 6. Like this, right?
Yes.
To be the 10 plus 6 is up.
No, look at the.
Try it like this. What does it give you?
This one
Okay,
works.
okay, that means
You should get a positive answer.
This one works.
And it should be a large number also. You get a positive answer that it's a large number. What does it give you this way? Just substitute now. I said you get y in terms of c. Abi? Just substitute now. You don't need to write it. Just put it in your calculator and substitute. Eh? Look at that equation on the board. I said get y in terms of c. Wasn't that what I told you to do before? The one you have done, substitute c. Oh. You can't see y there.
Subject of
No,
formula.
no, I'm not asking where's.
So what did you get y to be now?
What did you get white to be now? Yeah.
Is it that you don't know what to do or you are not sure of what you are doing?
Chill,
Okay, still a negative answer.
Still.
What did you get y to be?
Minus
Minus 5.02 times 10 to the power 4. No. Y as a function of c, that's what I'm asking you. Y as when you simplify that, what did you get y to be?
Okay,
Yes,
64.4 divided by
Divided by
minus 1,800. Let's say 1,800.
what did you get y to be? No. I said get y as a subject of the formula. You don't know how to do that thing.
Please.
Yeah, over what?
Yeah, that's
Minus
No,
I
1,800
just
squared
wish you have it like that because there's zero in the
plus 64.4. Everything minus 1.
So now for the calculator.
Divided by 7 divided by 6.
This small, right?
everything now.
Yes, no player divided by 6.
What did you get? Did you make y the subject? Did you make y the subject? You didn't do it before, no?
I know that.
That was what I said you should do initially now. Did you get y in terms of c? Who did y in terms of c? Nobody, you were just giving me answer. No?
I say it's still good.
Okay, I think I'm going to
Which we yes,
I got it on your phone. But like, I can't see. I can't see.
Okay.
One more simple instruction. Make y the subject of the formula. Only one person did that.
Why
this
doing
is
it?
minus
Can't
1
say that
divided by c.
I can't see process of making white.
Or this thing now.
Let me see what I do. Let me tell you that.
Okay, no problem. So move 1,800 to the other side. We're going to get, then divide 100 by 64.4. We're going to get something like this. 1 over c into 1 1 plus cy. It's okay, please, people, I just look at what we are doing now. C into 1 plus cy minus 1 over c, okay, is going to be equal to minus 1800 squared over 64.4. Do you understand that? So 1 over c into 1 plus cy is going to be equal to, when you move c to that side, have 1 over c minus 1800 squared over 64.4. Is that clear? So I can put these two together. When I do that, 64.4c into, so I have this to be 64.4 minus 1800 squared c. Is it clear? Okay, this is 1 over c into 1 plus cy. Do you understand what I'm doing? So we can invert both of them. When you invert both of them, or just c we cancel this c, then you can invert both of them. You're going to have 1 plus cy is equal to 64.4 divided by 64.4 minus 1800 squared c. Is that clear? So from here you can move 1 to the other side. So this is going to carry minus 1. This will be off. You can divide by c. Do you understand that? So you're going to have c into this. Is it clear? Sorry. C will divide everything. Do you understand that? C into this into 1 over c. Or just put c in the denominator for all of them. Let's not complicate it. So that's going to be our y. Does that make sense? So if you put in y now, what is it going to give you? If you put in c, so just enter this formula in your calculator. You know how to do that. Enter the formula in your calculator. You can now try different values of c. That's the way to work with something like this. So that you see.
So what's the answer? 915041.96.
Positive now, I mean.
I'm positive.
What were you doing before?
Enter the formula.
Now I told you to wait. Now me I tell you my.
You tell me the way to. All of you were telling me you got negative, you got small
I
number.
have to make down the right side of the formula.
I told you something before that when you get an answer, think about it. Does it make sense? When it doesn't make sense, something should already tell you that you've gotten or you've done something wrong, and then you have to go back and check. Enter the calculator. Enter it carefully on your calculator. It's going to be
They go fuck up exam.
64. Can you get anything for C? 64.4
Oh yeah.
So what's the value of x here? C. So the coefficient of this thing, please pay attention now. This should be 1 over 20.9 times 10 raised to the power 6 or 10 raised to the power 6 over 20.9. Did you get what I just said? Do you understand what I just said?
What did you say?
Coefficient of y. That's 10 raised to the power 6 over 20.9. So should we 1 over 20.9?
Who on that? Who on that?
You should 1 over 20.9 times 10 to the power 6.
See, you got to go to your
When you get
You get that?
Yes.
You said C to be equal to 1
to
over
get the formula.
20.9 times 10 to the power 6. Does that make sense? That is meant to be in brackets, actually. So we don't mix them up. Do you understand what I just said?
Yes, sir.
That denominator of C is meant to be, of Y is meant to be the coefficient of Y, the denominator of that Y, the original expression, is meant to be in brackets so that we don't mix them up like this. But when you do it the first time and you get a small answer or a negative answer that is very small, you should know that something is wrong somewhere.
Sorry.
Did you get that? Is this clear? Any issue, any problem? Can I move on?
Sorry, sir. Sorry. So how did you move from the third line?
This one?
Third
This one.
line. Yeah.
So this one?
Yeah.
Invert it now.
Okay.
Invert both of them. Can we move on? Yeah, you're going to solve for the second and third one the same way. The only difference will be the value of your initial velocity. Is it clear? Instead of putting 1,800, you put the other value. You go through the same process. Alright, so that is that about that. So I think there is something here. We have not solved a problem of the type A equals to F of B. So let's locate something like that and then we will. Look at 11.22. 11.22. So you have a problem of the type A is equal to F of B. Can you see that? 11.22. Are you on there? 11.22. The problem of the type A is equal to F of B. Can you see that? Alright, so give it a try. Solve it completely. 11.22. And that will be all. That means we've touched every aspect. You can practice all that in your own. So just for you to see how to go about the integration involved. 11.22. Made a mistake in the denominator. So this one related to outside. Equal to the v dt. You can also use a dx equal to v dv. Okay? You get what I just said? If you use a dx equal to v dv, you are going to have a relationship between v and x. Do you understand that? That can work. If you use the v dt is equal to what you are given, you are going to have a relationship between v and t. So which one should we use? Ask yourself what is required by the problem. What are the problem asking to find? Both of them. At least you can use any of them. Integration, the problem. You know that integration is the major problem here now. Do you know that integration is the major problem? No. Okay. Good to know that. If you don't know integration, maybe you go and enroll for FTH 102 class. It's like we're doing it together with 204. So I'm supposed to forget everything they taught me. I told you last semester, some of you are looking for it to come out, it will not come out.
Minus.
The time you should bother about whether it will come out or it will not come out, let me tell you this. When you should bother about whether it will come out or it will not come out in the exam, is when it's maybe the week of test or the week of exam. That's when you can begin to look at what's the possibility of them asking this or asking that. At this stage, you should understand everything because we will use them later. Do you understand what I'm saying? For instance, if you are in part 1 and you're bothered about what will come out and what will not come out, now you will be having problems because you would have issues with integrating by now, which is another problem you have created for yourself. When you were looking for what will come out and what will not come out in part 1, if you are looking for what will come out and what will not come out in part 2, you have abundant problems in part 3. Abundant, like enough of them.
That's why
Enough to go around.
And I did not go ahead to negotiate.
After the integral will come out. Okay. Get x in terms of that means you are solving the problem. That's basically what it is.
Minus.
Hey!
You run your case 20.
Okay, everyone got 8.
Then you can check what's out.
Oh yeah, what did you get? X in terms of t. How many of you got to x in terms of t? What did you get? Okay, tell me what you got.
Minus K12 and 4. Over 12, sorry. Open another bracket. C minus 18 over K.
C minus 18.
18 over K.
It's like this.
Close the bracket.
Yo.
Keep this one.
The other one.
So for it.
Hey, mom. Yes, because minus 2. Open bracket. Minus 3. All over 2. Close bracket. This power. All over.
K squared. K ló tún gbé square.
I'll get you this one.
Okay, K squared.
Me, I don't want you, but I have to try to go.
Oh, yeah.
Plus 81C.
You see that this one seems not appropriate. It is decreasing. The power is
Alright,
decreasing.
listen. No, listen, where did you start with? Okay.
It's true.
It started with A equal to B.
Yeah.
Do you understand that?
No.
To arrive at this.
But 81.
Started with A equal to division. What did you start with? Same thing. What did you start with? Okay, everybody started with A equal to the DBT. And then when you got V, you integrated again. I mean, to get X in terms of T.
Yes.
And you arrived at this. You think that they are all equivalent. Is it possible that they are equivalent?
All those
Wait. Okay, if I bring out this is.
oh, wait till this.
Okay, this is 18. Let's see if they are equivalent.
Let me see if I make it.
Okay, it's possible they are the same. It's possible they can be the same. So I want to have C alone. Okay, let's see if I can factorize this. So minus 2 over 3k into, let's have this to be minus k over 2. Now do minus k over 2 into C minus, you know what I'm doing? If I bring out that minus k over 2, it's going to become minus 18. It's going to be minus 18 over k. You understand what I'm doing? All raised to power 3. Is that there? You get what I'm doing? When you bring out minus k over 2 from here, minus k over 2, you have, is it clear? When you open the brackets back, you're going to have this to be plus 9. Do you understand that? And then k will cancel k. Does it make sense? When you raise it to power of 3, you're going to get that. And then from here, you are going to get, when you raise it to power of 3, minus k raised to power 3, you're going to be minus k cubed. Did you get that? So that's going to be minus 2 multiplied by minus k cubed. Is that clear? Then 2 raised to the power 3 is 8 divided by 8, then multiplied by 3k into t minus 18 over k raised to the power 3. Does that make sense? You understand what I'm doing? Okay, so each k we cancel one of these. Is that clear? This minus we cancel this minus. 2 here will be 4. So what I have here will be k squared over 12. Do you understand that? That will be k squared over 12. Do you understand that? So what's the only issue? The only issue is minus. There's minus sign difference. So I think they are the same. So if you open this bracket as well, most likely it's going to be the same thing as this. If you open this bracket, you might get exactly the same thing as this.
What did I say?
Okay, there's no minus. But I didn't move the minus when I squared.
Why you call it doubt?
This one I mean, okay, so both of them are correct. Both of them are correct.
Forget, I follow you.
You get that? They are both the same. Is it clear? Okay. If you square one of, if you open this bracket also, it is likely that you come across the same thing as this. Is it clear? You understand? So that's why it's not good to know. If you don't, you be like, what I've done is wrong. You cancel everything. Okay, so when you open this bracket, for instance, you might get the same thing as this. We type this also, we know the answer like this is more right here. If you do this, what are you going to get? You're going to have something like this. C minus 18 over k multiplied by, when I square this, it's going to be t squared minus 2 times this. That's going to be 36. Do you understand what I'm doing? C squared over k squared, like this times this rather, c over k. Let's see c over k. This is going to be 18 c over k, then multiplied by 2. That's going to be that. It's going to be plus 18 squared over k squared. When you open this bracket, what does it give you? It's going to give us 3 times this. That's going to give us 3 raised to the power 3. And I'm going to have this to be 3 raised to the power 3 multiplied by 3. That's minus 36 c squared over k. Then 3 times this. What's 18 squared? What is 18 squared? That's going to be equal to plus 3 to 4 over k squared. Then let's use this. Minus 18 c squared over k. Then this times this. 18 times 36. 648. 648. That's going to be plus 648 c over k squared. Do you understand what I mean? I multiply this and this. I multiply this and this. 18 times 18 squared, what does it give you?
5
divided by k raised to the power 3. Is it clear? That's what you get here. So when you multiply everything here by k squared over 12. Okay, let's simplify this first. What does it give us when you simplify? We're going to have t cubed. Okay, so let's multiply directly. Let's multiply everything here by k squared over 12. So when you do that, what do you get? So it's going to be k squared t cubed over 12. So I'm going to have k squared t cubed over 12. Does that make sense? Then, so the ones t squared, put them together. T squared over k. Add the 2, what does it give you? Minus 8, minus 36, minus 18. 36 plus 54 divided by 12. Minus 9 over 2. So, we are dividing by k, so you have only 1k left. Do you understand that? What did you guys do now? Minus 9 over 2. K like this, have you?
No, K.
But the thing is that
K is up.
you broke this one down.
So now there is K square outside now.
Wait. Minus 36 Abi?
Yeah, K is up.
Okay, K is up. K T square, right? Then the ones carrying T, what does it give you? 3 to 4 plus 6, 4, 8. 81 K squared T, Abi? 81 K squared T. Okay, K squared without K squared, Abi?
It's one.
Plus 81. Then the ones without T. The only one without T is this. So 5832 divided by 12. What does it give you?
486 over
That would be minus.
I'm the bracket and minus
Okay, you didn't add this course now. That's the only difference, I mean.
yeah.
Maybe you are probably correct, but there's something missing. Check. You're actually correct. The answers are the same. Except that that thing is not carrying 486 minus 486.
This guy did the same thing.
Got the same thing.
Yes, it's got the same thing. In the 1 minute,
Yeah,
No, no, just stop.
I did it. But this is what I was doing next time.
Okay.
You don't have that minus one.
Let me see.
That is called
No, but the third one is the answer.
you better talk about it.
That's really simple. I've been at the teacher of the answer.
I got some answers. Now,
If you
so they are
make it
trapped.
about make the
You integrated now. You need a proper integral.
Yes, yes.
I didn't get any constant. There should be a constant now.
Why exactly?
Can they all carry T? Is it possible they all carry T? Let me see what it is. Is it from 0? Okay, they are both from 0.
Are you serious? No, I'm serious.
How come they are different?
I don't think
That was the same.
Wow.
Yeah, but that was not just but just all that.
So let's do what you did. So to be very, very sure. So that we don't solve the problem. So what was A that you were given? A equals what? Yeah, let's do it together. Let's solve it together.
Minus K with
Minus K with B. Pay attention now, pay attention. That means the B, Abi, B equals minus K with B. So this is going to give you what? The B, so you can move this one here. 1 over root B, Abi. B equals minus K. Does that make sense?
Yeah.
What did you get? You get in 1 over root B, that's B raised to power minus 1 over 2, Abi.
Now, 2 root B, 2 root B.
You got 2 root B.
2 root B, yeah.
Alright, from what was the initial value?
81 to B.
Minus K. Okay, at C equal to 0, this was 81.
Yeah.
Okay. So this is going to give us 2 root B
Minus 8.
minus 2 root 81, right?
Yeah.
Equal to minus K. Is that clear?
Yeah.
So what does that give you?
2 root B minus 8.
2 root 81 is 18, Abi.
Yeah.
You are going to have this to be 2 root B. You can divide 2 by 2, Abi. Root B.
Yeah.
So you want to move this right here.
Minus
So
9.
this is 18, Abi.
Yeah.
So It's going to be 9. So put it there, it's going to be plus 9. It's going to be 9 minus k over 2. That makes sense?
Yeah.
So you can then square both sides. You're going to have this to be v is equal to 9 minus kt over 2 all squared. That means x is equal to 9 minus kt over 2 squared. Then integrate this. That means integral of s is equal to 9 minus kt over 2 all squared.
Integral.
So what were the
0 to x.
when x equals to 0, Abi?
Yes.
Okay.
2 0.
2 or 0.
T, yeah.
So this is going to be x minus 0, that's x, Abi.
Yeah.
The integral of this, that's going to give us what?
9.
Integral with respect to the core, Abi. That's going to be 9 minus kt over 2 raised to the power 3, Abi. Divided by 3, Abi now. Then divided by the derivative here. That's going to be minus k over 2, Abi. That's the same thing as multiplied by minus 2 over k. Is that clear? You understand that? What did you do?
Actually, it's everything.
When I go that V
You
first,
expanded.
I
Let's not get something different now.
how is fixing this is what I experienced.
We have established that both of them are equal. We have established that both of them are equal. Okay, let's try what you did. So when you expand this, you're going to get v equal to 9 squared, that's 81, minus 2 times p, that's going to be 9k, then plus k squared, squared, you're going to have this to be s equal to, when I integrate now, integrating directly, it's going to give me 81 minus 9 k square 2, Abi?
Yeah.
Square my plus
K square. About 12. Yep. Yeah, that's it.
Okay, that's the difference. That was what you got.
Yes.
Wow.
How come this is different?
Check the expansion of that.
Because you call it answer now.
I think both of them are okay. Let's do twins of them.
Check the expansion of that.
It's okay. Let's solve the problem. So we use each one of them. So you see, I think they are the same. Or they should give us the same answer. Okay. They should give us the same answer. So look at something like I told you something the other day when I taught you differential equations. There was a situation where we used 2 different methods and we had one carrying 1 over 27 and the other one was not carrying 1 over 27. Can you remember that differential equation? And I told you that both of them are the same because one is carrying 1 over 27 plus c, the other one is just carrying c. Did you get that?
Oh, yeah.
It just means that the constants will be different for the 2 of them. Do you understand what I'm saying?
Yeah.
But you're going to get the same result at the end of the day. So that kind of situation. So either of them should work fine. So how do you solve the problem now? What have you been asked to find? Look at it. It says you should get the velocity of the particle when x equals to 20. Okay, you still don't know the value of k, Abi? So you need to obtain the value of k. And to do that, please listen now, listen. To do that, listen, ideally, this should have actually guided your choice of starting point. Okay? Look at something now. Now, ideally, you should have started this way. A dx is equal to v dt. So you can get a relation between x and v. But it's okay if you didn't start like that. It's fine. So look at this now. We want to get, so we are given this. We are told that that x equal to 0 and v equal to 81 at t equal to 0. Can you see that? And they said v equal to 36 when x equal to 18. Is it clear? So that means that when v is equal to 36, it is the same time that x is equal to 18. Is it making sense? So I will substitute v equal to 36 and find the time at which that will happen. Then I will also substitute x equal to 18 and find the time at which that will happen. Then I equate the two times. Is it clear? That will give me the value of k. Does it make sense? Did you get what I just said? I will find out the time at which v equal to 36. I'll substitute 36 here and make t the subject. Do you understand that? Or solve for t. And then I will also substitute here x equal to 18 and solve for t. Then I equate the two times. Is that clear? So that will give me the time at which x equal to 18 and v equal to 36. Does that make sense to you? Yeah. Well, that's the way to go about it. I think it is going to unnecessarily complicate issues for you. So if you had gone this way, if you had started this way, you would be able to get v as the function of x. Do you understand what I'm saying? By the time you integrate this, and with that, you can use this condition right here. Do you understand what I'm saying at all? You can use that condition. When you get v as a function of x, you can use this other condition to evaluate the constant. Is it making sense? Is it making sense to you? And then that will solve your problem. So, if you go here now, please listen. If you come here, what is going to be the time at which this will be? Please listen very well. So we say when x equal to 18, what is going to happen when x equal to 18? That means we are going to have 18 to be equal to that. 18 will be equal to 81 t, abi, minus 9k squared over 2. Then plus k squared over 3 over 12. So, yeah, so it will be easier to solve when you use this. Do you understand what I'm saying? It will be easier to solve for t when you use that expression. You can easily get c in terms of k. Does that make sense to you? When you use this expression. Do you understand what I'm saying? This one. When you use this one, you can easily get that expression. So let's use that. That is going to give you what? That's going to give you minus 2 all over 3 into 9 minus 8 over 2 all raised to the power 3. Is that clear? So I can make t the subject right here. So how will I do that? When I cross multiply, when I divide, I'm going to have minus. When I divide this by this, I'm going to have minus 9. Do you understand that? Multiply by 3, that's minus 27k equal to 9 minus kt over 2 all raised to the power 3. Is that clear? Then I can take the cube root of this. Abi, cube root of minus 27 is minus 3, right? This is going to be minus 3. Then cube root of k, that's k raised to the power 1 over 3. It's going to be equal to 9 minus kt over 2. So with this, I'm going to have this here, kt over 2 equal to 9 plus 3k raised to the power 1 over 3. From here, I'm going to have t equal to 2 into 9 plus 3k raised to the power 1 over 3. All divided by k. That's t in terms of k. Does that make sense? Does it make sense? Cube roots. Minus 3. The minus will return by the time you do the touch. Do you get that? The square root of negative that you can't find. Or even root of negative number. Can you remember that? You cannot find. Okay, so this is going to give us for v now. What was the v we obtained earlier? This was v. So I find out the time at which v will be 36. Is that clear? At the same time, v is 36. So I'm going to have 36 equals that. That is going to give me 9 minus 80 over 2 all squared. Please pay attention. I've addressed this several times. This stupidity of discussing while I'm talking on the board. It means that when I'm done, you still want to ask me a question on what I've explained. Please, you should know the proper thing by now. Listen, when I'm done, ask me a question, or you want to discuss, you can discuss when I'm done. So this is going to give you 6. 12 plus 36 is 6. This is going to give you 9 minus 80 over 2. From here, you can make t the subject. That means 80 over 2 will be equal to 9 minus 6. Which is going to be 3. From here, I'm going to have t is equal to 2 2 times 3, that is 6 over k. So I can equate these two. Is that clear? So I'll now say that therefore 2 into 9 plus 3k raised to the power 1 over 3 1 over k is going to be equal to 6 over k. So this will cancel this. 2 needs to give us 3. So I'm going to have this to be 3k raised to the power 1 minus 9, right? This is going to give us k raised to the power minus, sorry, k raised to the power 1 over 3 equal to 3 minus 9 is minus 6 divided by 3, that's minus 2. Now I'll take the cube root of that. I'm going to raise to the power of 3. It's going to be k equal to minus 8. Does that make sense? Now raise to the power of 2. So with that, we now have our k. So with this, you can solve for the unknowns. Okay. What's the issue?
Yes.
V and X are do you get this? Did you get that? So they said you should determine the velocity of the particle when x equal to 20. So that's another issue now. Another issue we have created is because we did not get a relationship between v and x, now you have to find out the time at which x equal to 20. Use that time. So you understand that? You get your v. You understand what I'm saying? So when x equal to 20, what is going to happen? X equals to minus 2 over 3k. That's minus 3 times minus 3 times minus 8. That's minus 24 into 9 minus, this is minus 8. That will become plus 4 raised to the power 3. Do you understand that? This means x will be equal to 1 over 12 so 9 plus 40 raised to the power 3. And then when you substitute for v, v will be equal to this. That will be 9 minus, so this is minus 8, that will become plus 8 over 2, that will become 4 raised to the power 2. Okay? Is this correct? There's an issue here. Okay, when you differentiate this, does it give you this? Okay, 3 over 12, that's 1 over 4, okay, multiply by 8. Okay, yes, give you that. Do you understand that? What you use what?
Like the X and B down,
X and B?
like when I go to that one,
I changed the one you said it was mistake before. The minus
Computer.
thing was mistake.
I wrote the minus.
What did you do? Same thing that I did on the board.
We made it the subject now.
That means you did the
So
same
the
thing.
X was quoted there, but my K was.
So there's an error here.
I don't know. Like I don't say it's different.
How come?
You said what did you get?
You use your answer now.
You got it.
So that's not your answer.
I know. Now that first sample. How do you differentiate it?
I didn't differentiate, but I just took it. I'm saying when you differentiate, you must give you the same results. Did you get that?
Okay, now you know.
When you differentiate B now, what do you get? Bring 2 down, Abby. That will be 2 into 9 plus 40, Abby. Then multiply by derivative, that's multiplied by 4, Abby. That's going to be A is equal to 8, Abby, into 9 plus 40. Does that make sense? Okay, 9 plus 40 is square root of B. Do you agree with that? Do you understand what I'm saying? 9 plus 40 is square root of v. That means a will be equal to 8 root v. Does it make sense? Which is the same thing as k root v that we're given. Minus k root v that we're given. Does it make sense to you? That confirms that what we've done is okay. So, you can now solve the problem. So they said you should find the velocity of the particle when x equals to 20. So again, I said I didn't think you got a relationship between v and x, you just substitute directly. But now we don't have that. So when x equals to 20, what is going to happen? So we say when x equals to 20, I'm going to have this to be 20 equal to 1 over 12 into 9 plus 40 power 3. So what does this give us? 12 times 20. What's 12 times 20? 240. What's the root of 240? 240 is equal to 9 plus 40 raised to power 3. What do you call the cube root of this?
This 11.
4 roots.
15.
I will see how that question I know.
Very good. How do you know this cube root?
This is the same.
Very
11.2.
I don't think they're going to that one.
You have to break it back to normal form.
6.21.
No, we expanded it. You have to take it back.
So I'm going to have 40 equal to 6 points.
But if you say divided by 2,
6.21 minus 9.
I'm not trying to see that.
It cannot be negative.
That's that. No, please, just take care. There is no kind of factor.
It cannot be negative. Should have obtained a relationship between
you should
V
have
and
just done that normal
X.
relationship.
Let's see if we can attempt that there. Please pay attention now. You know that from here I can say that v squared is equal to
Very simple.
9 plus 40.
I have.
You know they don't
Or I can say that 9 plus 40 is
This is a good
equal to, please pay attention, 12x. Okay, everything there is power 1 over 3. Does that make sense? So, I know when I square this, that means 9 plus 40 all squared should be equal to 12x raised to power 2 over 9. That means v is equal to 12x raised to power 2 over 3. And I can say v is equal to, so when x equals to, when x equals to what? When x equals to 20, what is it going to give us? It's going to give us 12 times 20 raised to power 2 over 3. What does it give you, please? Huh? 38.62. What's the unit? Meters?
Yes.
Meters per second. What was the answer? Somebody should check the answer.
Why did you go not give us this?
You should want. Yeah, I dodged that because of some reasons. I promise. I don't think that should give us different answers. The fastest way to absorb this problem, like I said earlier, was to get a relationship between x and v. However, this difference in results should not have reason for any of these.
Special. I found way around this 36. Found way around it, but then you do expressions. Please, guys, what is it about this or 21?
Cannot like we change voice. Was him no one but delete
But what I'm telling you is, you should have obtained the same result. Because all the equations are correct. You should have obtained the same result. Okay. Okay, I'll check it. So assignment for you. Hello, listen now. Go and use the ADX equal to BDB approach. You have enough details to do a proper integral and also enough details to find K. You understand that? You have enough relationship between B and X. So you have two relationships between B and X that were given. So you can use that. Are we together, please? Are we together? You get what I just said?
Sir, I have a question.
Sape, I'm not the right class. At what? You use it now. You use it in your proper integral. When you are done, you now use the second one to find K. You get that? So do that on assignment. I will just obtain the same result. I can find out the solution that we have. Normally when you look at the details given, you should know the fastest means to get to your solution. So looking at the details given already suggests we should have used ADX equal to BDD. However, taking the long distance should not mean a wrong result. So that's what I want to say. But you can do the proper one as assignment. So we'll continue from here in the next class. Thank you for coming.